Good day, everyone. Today we're gonna shift the focus to the resistors that are connected in series. We're gonna shift the focus to the physical science, and we're gonna look at the resistors that are connected in series and the resistors that are connected in parallel. So now, for those of you that they looked into the introduction of the video for the electric circuits. I think that I discussed only the Ohm's law and the Ohm's law equation. So now we're gonna look at the resistors that are connected in series. Then we look at the resistors that are connected in parallel. I want you guys to know that resistors that are connected in series, they are potential dividers. What do I mean by that? It means that for V total in each of the resistance, for V total, that means that the V total is the voltage for the whole cell. And now for each of the resistors that are connected in that cell, it means that the voltage is divided according to their value of the resistor. So let's firstly write that resistors in series are potential dividers. Resistors in series are potential dividers. Potential dividers. They are potential dividers, and now I explained that potential difference in the last video. Potential difference is the voltage. Then in the circuit you have V total, and you may have maybe a V1, V2, and V3, and all that. It means that these voltage are connected in resistors, connected in resistor 1. This means that it's connected to resistor 2, this one. Now for you to get the total voltage, you have to sum up V total is equals to V1 plus V2 plus V then plus Vn here. Yes. The potential difference across the circuit, V total for the cell, is made by V1 plus V2 plus V plus dot 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 plus Vn. It means that for resistors that are connected in series, they divide the potential difference. Let's look at it like this. Here we have our cell. Here is the positive terminal and the negative terminal connecting an ammeter, then resistor 1 here, and resistor 2 here. Then we join this. It's resistor 1, then it's resistor 2, then this one is an ammeter. We have a voltage across the terminals of the battery. That's our V total, our potential difference for the cell. Now that I said that for the resistors that are in series, they are potential dividers. I mean that for for this cell, we have a V here, V1 connected in resistor 1 and a V2 connected in resistor 2. V1 and then V2 here. If you can take note of this, the current here that pass through R1 and R2 is equal. Current in resistors that are connected in series, current is equal. Current for, let's say, I R1 is equals to I R2. Here, I R2. The resistors that are connected in series, they only divide the potential difference, of which the potential difference here is V total. Here, they divide the V total up according to the resistors, the amount that the resistor contain. If it's 2 ohms, maybe if it's 1 ohm, and here if it's 4 or 5, they will divide that potential difference according to their amount. And if you sum up the voltage of V1 and V2, they will give you the total voltage for this cell. So now it means that I said that the current here that flows from the positive terminal of the battery, it passed through this ammeter, and the ammeter reads the current, and then the current that passed through that ammeter will definitely pass through R1 and pass through R2, and then it goes back to the cell of the circuit, and the current that passed this voltage and this voltage is equal to the current that this ammeter reads. So the current here, I said the current here is equal for I R1 and is equals to I R2. They only divide the potential difference only. All right, now I think we have to look at the resistors that are connected in parallel. Okay, I have a little note there. But anyway, let's continue. Now, the resistors that are connected in parallel. The resistors that are connected in parallel. Resistors in parallel. Are parallel. Here, the resistors that are connected in parallel. For resistors that are connected in parallel, they only divide the current. The resistors that are connected in parallel, I'll just put R here for resistor, connected in parallel, they divide the current. They divide the current. I'll say I here for the current. Now, since these resistors that are connected in parallel, they divide the current. Now it means that for V total, the voltage, the potential difference for the circuit of V total is equals to V1 is equals to V2 for resistors that are connected in parallel. But V total is equals to V1 and V2, or up until to Vn. So now we can have the R external. For R external, here for R external, for the parallel, for the resistors that are in parallel, R external is equals to 1 over R1 plus 1 over R2 plus dot 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 plus 1 over Rn. Or maybe you can use another way of calculating R external for the parallel one. Rp is equals to R1 R2 over R1 plus R2. But this one is, you can use it when the resistors that are connected in parallel, they are only 2. So you can use this one, or maybe use this one for resistors that are over 2. You have to take note here. You have to use it for resistors that are connected in parallel, and or specifically when they are 2, the resistors that are in parallel. So I talked about the Rp and V total, that is equals the total voltage is equals to V1 is equals to V2. It's not divided. The only thing that is divided is the current. So the current here, I total, is equals to I1 plus I2 dot 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 plus In. You see? So they divide the current, and when they divide the current here, they make that the current for the whole circuit they make the current for the whole circuit when you add I1 and I2. So I talked about the current that is divided, and now let's look at the circuit. Here is the circuit, positive terminal, and then an ammeter here. This one is I total. Here, this one is I total, and then negative terminal of the battery. Then you find a resistor here, and then another resistor R2, then this one is R1. So here you can see that the current flows from this direction and go past this ammeter. This ammeter here reads the current that flows, the rate of the current that flows pass through this ammeter, and then you can see that the other current, they go this direction, and the other, they go this direction. So here we divide our current, but the potential difference is equal. For V total, V1 here, and then V2 here. So for the V1, the total voltage is all equal. It's not divided here. The only thing that is divided is the current that flows in the circuit. So the current flows this direction up here, and then meet the one that flow from this direction, and then they meet, and they make the total current that flows for the circuit here. If you can take note here, there's only thing that is divided is the current, as I said here earlier on, that resistors that are connected in parallel, they divide the current. So now you can see that here the current is divided from here. The other current flows this direction, the other current flows this direction. So that one, those things that I said about the resistors that are connected in series and the resistors that are connected in parallel, that they are potential dividers, and others they are current dividers. You can take note of that because it does help out a lot when it comes to solving the problems for